Introduction: Mars, humanity's dream or planet of doom? For decades, Mars has fueled the imagination of scientists, sci-fi writers, and billionaire visionaries. Colonizing Mars is often seen as humanity's backup plan, a laboratory for survival, a symbol of technological triumph, and a key to becoming a multi-planetary species. But Mars is no second Earth. It is a cold, dry, brutally hostile world where every mistake could mean death. What are the real dangers waiting for the first settlers on Mars? What must they be ready for to have even a chance to survive? Extreme cosmic radiation. No shield for survival on Earth. We are protected by a strong magnetic field and a thick atmosphere that block deadly cosmic and solar radiation. Mars? No global magnetic field, only small, patchy remnants in ancient rocks. Very thin atmosphere, only about 1% the pressure of Earth's. Consequences: Mars's surface is constantly bombarded by cosmic rays, galactic and solar. Long-term exposure increases risk of cancer, DNA damage, and tissue degeneration. Solar storms can deliver a lethal dose of radiation in just hours. How to cope? Colonists will need to live underground, in lava tubes or artificial tunnels, or under thick shields made of regolith, special polymers, or water tanks. Immediate shelter is mandatory during solar storms. Constant space weather monitoring will be a matter of life and death. Low gravity, the silent breakdown of the human body. Mars gravity is just 0.38 g. You'd weigh only about a third of your Earth weight. Fun for a few jumps, but devastating for long-term health. Risks: rapid loss of bone density and muscle mass, even faster than on the ISS. Impaired circulation, weaker immune system, risk of heart problems, dizziness, and loss of spatial orientation. Children born on Mars could suffer permanent developmental issues, possibly making a return to Earth impossible. How to cope? Intense daily exercise, mechanical exoskeletons, or, in the future, artificial gravity, centrifuges, still science fiction. The long-term effects on genetics, reproduction, and fetal development remain unknown. An atmosphere of pure carbon dioxide, no oxygen, no life. Mars atmosphere is 95% CO2, the rest mostly argon and nitrogen, with just 0.13% oxygen. Average pressure: 610 pascals, about 1% of Earth's. Temperatures range from minus 140 degrees Celsius at night to plus 30 degrees C at the equator by day, with an average of minus 60 degrees Celsius. Implications: you cannot breathe outside. Suffocation and decompression would kill you in seconds. Any liquid water exposed to the surface instantly boils or freezes. How to cope? Hermetically sealed habitats with controlled pressure and artificial atmospheres. Oxygen generated via water electrolysis, if water is available, or MOXIE-type tech, splitting CO2. Any malfunction in life support could spell disaster for an entire colony. Extreme cold and temperature swings. Mars is a freezing planet with wild temperature swings. Nighttime lows: minus 100 to minus 140 degrees Celsius. Daytime highs at the equator can briefly hit 20-30 degrees Celsius, but it's usually well below freezing. Sunlight is just 40% as strong as on Earth. Risks: habitats and spacesuits must be highly insulated and constantly heated. Heating failure, equal sign hypothermia, or death within minutes or hours. Batteries and electronics become unreliable or brittle in the cold. How to cope? Double-walled insulation, vacuum layers, robust heating systems, likely nuclear-powered. Underground shelters offer more stable temperatures. Water and supplies must be stored safely, protected from the cold. Dust storms and Martian sand. The deadly grit Mars is infamous for its global dust storms. The dust is ultra-fine, sharp, electrostatically charged, and gets everywhere. Spacesuits, solar panels, machinery, airlocks. Storms can last for weeks or months, blocking sunlight and choking solar power systems. Dangers: loss of power, failures in filtration, damage to mechanical parts. Breathing in dust could cause severe lung damage. Abrasion of spacesuits, seals, and machinery increases risk of catastrophic failure. How to cope? Backup power systems, nuclear batteries, cleaning protocols, electrostatic wipers for solar panels, airlocks with thorough decontamination routines, advanced filtration and containment for all incoming equipment and people. Lack of water and food. Survival at the edge: without water, there is no life. On Mars, water exists mainly as ice, deep underground or at the poles. Dangers: extracting water is difficult and energy-intensive, mining, melting, purifying. Most water and food must be recycled. from waste, condensation, and gray water. Hydroponic farming is vulnerable to tech failures and resource shortages. How to cope? Closed-loop water recycling, advanced filtration, ice mining, and efficient extraction tech. Artificial greenhouses with controlled climates for crops, possibly algae, insects, or genetically modified plants. Redundant stores of emergency food and water for months at a time. Psychological and social hazards, isolation, depression, conflict. Mars is the most isolated place imaginable. Crews are confined in small spaces, millions of kilometers from home. Communication with Earth has a lag of 424 minutes one way, no real-time conversations. Months or years with no way to return home. Dangers, depression, cabin fever, interpersonal conflict, team breakdowns, risk of suicide, psychosis, loss of motivation. Hierarchy and division of labor may become major stress points. How to cope? Careful psychological screening, team building, isolation training before departure. Virtual reality, digital communication with family, conflict prevention protocols. Well-designed interiors, opportunities for movement, privacy, and recreation. Medical risks, limited care, injuries, and disease. There will be no fully equipped hospital on Mars. Injuries, burns, infections, acute medical events, appendicitis, heart attack, fractures could be fatal. Problems, limited medical supplies, no blood bank, little capacity for surgery. Any serious illness or trauma could end the mission, or a life. Every crew member will need medical cross-training and basic surgical skills. How to cope? Cross-training in medicine, telemedicine, robotic assistance, 3D printing of tools and some medications. Emphasis on prevention, health monitoring, and ultra-careful selection of crew members. Technical failures. The greatest Mars threat. Mars is utterly unforgiving. Failure of oxygen, power, heating, or water supplies could kill the entire colony within hours. Every critical system must be redundantly backed up, with plans B, C, and D. Spare parts must be produced on Mars, with 3D printers in situ manufacturing, as resupply from Earth could take months or longer. Ecosystem risks and biological contamination. Mars might still host native microbes or remnants of ancient life. There is a risk of contaminating Mars with Earth bacteria, or vice versa. The first Mars-Earth biological contact could theoretically unleash a Martian pandemic. More likely science fiction, but history warns us to be careful. Long-term survival. Adapt or die. Will humans be able to live on Mars for generations? Genetic changes, evolution of new traits, Martians versus Earthlings. Will return to Earth even be possible? Or will Martian colonists become truly isolated? Sci-fi scenarios and unknown threats. Marsquakes, landslides, polar ice avalanches, asteroid impacts, failures of orbital infrastructure. Unknown physics and phenomena never encountered on Earth. Mars. For heroes and the fragile alike. Colonizing. Mars isn't an adventure, it's a test of the limits of our technology, biology, teamwork, and courage. Every mistake, every accident, every weakness could have deadly consequences. Survival on Mars will demand resilience, teamwork, new technologies, and a humble respect for nature. But that's exactly why Mars calls to us. The greatest dangers are also the greatest adventure.